Hey, so I know that recently we studied piecewise defined functions, which are a very new concept to almost all of you at this point in time. Sometimes we cover them in Algebra 2, but last year it definitely didn't happen, and it's not a big deal. But remember, in math, we actually use equations to try to model what happens in a real-life situation. And sometimes one single equation is just not up to the task. It may be far more complicated, and so there may be a region of time where one equation seems to match the data that you have, and at other times, a different equation matches the data. So what I'd like to do is just kind of go over it very quickly, as well as show you in Desmos how you could check what you're doing. So let's take a look at the following. So what we are going to do is look at a very simple function. I'm going to call it g of x. Now, g of x is a piecewise defined function, meaning it is comprised of multiple pieces. So what I have is some of the graph is just looking like a downward sloping parabola, and some of the equation is looking like just a nice little uphill line. Like, in fact, it's the line 2x plus 1. Now, as it turns out, this line right here is actually only the parabola for values of x that are less than or equal to 0, and the line exists for things that are above 0. That's still a function because this would only exist for values below or equal to 0, whereas once you hit above 0, it jumps to this one. So if you're ever asked to say, go find a value, if someone said, hey, can you tell me what g of 7 is? Well, 7 is actually part of this piece. The value of x is above 0, not below 0, so it would be this one. So g of 7 would say plug 7 into the bottom equation, which would give us 15. Whereas if someone said, hey, can you tell me about g of negative 8? Well, negative 8 actually lives in this region right here. It's a value of x below 0. And so that would tell you to take the opposite of x squared, where you made it negative 8, and so I would actually get negative 64. Now, that's a little bit about just evaluating. Now, if you were actually asked to graph, and on your next exam you will be asked to graph, this is going to look like a little downward sloping parabola, like 0 squared is 0, 1 squared is 1, but with the negative in front it goes down. Negative 1 gives you negative 1. If I tried negative 2 squared would be actually positive 4, but then it'd become negative 4. So notice I'm plotting a few points so that my graph looks kind of nice. And so what I see is a portion of a parabola, but notice that the parabola stopped when it reached 0 because the domain says it's no longer a parabola once I reach that value. Now, this should be a line, so I should start at x equals 1, and I should have a slope that rises 2 and runs 1. And you'll notice as I did that, I actually went ahead and made it an open circle here at x equals 0, because this says I can get very, very close to 0, which would give me something very close to 1, but it cannot be exactly 1. So that's a quick example of how that works. Obviously not doing a whole lot with that information. There we go. That's the orange portion of the graph that kind of goes in that way. So I made another little function right here. So I took the time to graph it already in advance, so I wouldn't have to take the time to show you all of my steps. But remember, an absolute value should look like a V. So please notice that this portion of the graph right here stops at negative 1, and notice that because at negative 1 when I plug it in I get 3, and this does tell me I can use that. This should be a solid dot at 3 because we can actually have it. Then the next little piece of the graph from here to here looks like it's some kind of a parabola. Notice I had an open dot at negative 1 because I'm allowed to get close to it but not touch it, but I have a closed dot at 2 because even though that looks a little scribbled, it was supposed to be or equal to. Now you'll notice if we go one step further, I hope this pen actually is going to show up, it became a horizontal line for a small period of time right in here, from here to here, from 3 to 5, at which point in time the last little piece of the equation is it became a square root function. So if you were asked to say something like find f of 4, 4 is not below -1. It's not in here. It's actually right here. And this says no matter what x is, if it's anything from 3 to 5, that answer would be, in fact, -3. If you were asked to do f of -8, well, -8 lives in the yellow region. It's the only thing that actually would work. And so if I plugged in -8, this would give me the answer of 4. F of 19 doesn't exist in this region. It's all the way down here. It's a value that's significantly above the number 5. So if I plugged in 19, I would get the square root of 14. So you really have to look and pay very, very close attention to which equation you're looking at. Now, what I wanted to do next is show you that we could actually take a look at desmos and check our answers in desmos. Now, this is a little harder for people to do, but in desmos, it's programmed to allow you to do piecewise defined functions. So if you start with f of x equals and you do a brace, that just starts the story. And the protocol that they give you is you say, first you have to tell it where you are, which is x is less than or equal to -1. You do a colon, or I believe that's a colon, what you are. And that was the absolute value of x plus 4. And if you look at it, that kind of looks like the graph that I had a moment ago. Now, I could be done with my problem, but if I want to add to it, I just hit a comma, and then I could say where I am again, which is -1, is less than x, is less than or equal to 2. Remember we said then the colon, what you are, which was x squared. So you'll notice the second portion of that graph exists, comma, where I am, less than or equal to, x is less than 5, what you are, -3. So now we see that little chunk exists down there, comma, and then the last one was where I am, which was x was greater than or equal to 5, and what the equation is, which was the square root of x minus 5. So this is the whole story. So you could get a real feel for what your piecewise function looks like. But not only that, you can check your answers. Before we've said, hey, what was f of 4? And I think when we did that before, we said that that answer was, in fact, -3. And it did understand that that's what I wanted. Or if I wanted to do f of 19, it's going to give me kind of a strange answer of 3.74, but if you check, that is in fact the square root of 19. But it actually understands, based on this information that you put up here, what portion of the domain that you would be looking at. Meaning if I gave you a number like 2, that would be in the x squared portion, and it says, hey, what do you know, x squared is in fact 4. So that's a quick little look at how to take a look at piecewise defined functions, how to look at them, how to analyze them, how to graph them, and how to look at them on desmos. I hope that that was helpful to you, and let me know if you need help. All right, you guys have a good day.